Hi, this is my lab number 3, Black Hole Lab. The objective of this lab is to analyze the star's motion to find the net force on the star for all points in the dataset. Using the results of your analysis, estimate the mass of the black hole. Assumptions. Assume that the net force on the system is due solely to the gravitational force of the black hole. The name of the data file is stardata.csv. The mass of the stars in kilograms, the time step, and the position of the black hole in meters. We put this data in our Python code. The mass of the star, delta T, and there is the name of the data file. In this loop, we compute the x component of the velocity and the y component of the velocity. In this loop, we use the momentum principle. First of all, we define something. For example, the initial velocity and final velocity of the star, and the initial momentum and final momentum of the star, and finally the delta B and delta P, changing velocity and changing momentum. We observe that the net force is equal to dP divided by dt and approximately equal to delta P divided by delta T. This is also called Newton's second law. In our code, Fnet is equal to dP dt. In this trajectory, Fnet can be represented in two parts, the parallel component and the perpendicular component. A parallel component is related to changes in speed, and the perpendicular component produces curved paths. In the code, we observe the parallel component and the perpendicular component of the net force. Now we run the code and observe the simulation. The yellow arrow is the net force, blue arrow is the perpendicular net force, and black arrow represents the parallel net force. And black circle is the black hole, and the green line is the trajectory of the star. To calculate the mass of the black hole, we need to insert this line in Python code. Remember that the net force is equal to the gravitational force. Using this formula, we can find the mass of the black hole. This is the mass of the black hole that I found. Also, in the simulation data, we can observe the mass of the black hole. What does it mean? The component of the net force that is perpendicular to the momentum, Fnet perpendicular, turns the momentum in a new direction. To make an object turn to the left, apply a force to the left. The perpendicular component of the force, net force, points toward the center of the Kissen circle. And the component of the net force that is parallel to the momentum makes the momentum increase or decrease, and at a turning point it makes the direction reverse, but it cannot make the momentum turn to the left or the right. What if question? The answer is no, because if a different black hole is still placed at the same location and the motion of the observed star remains unchanged and is affected only by the gravitational force of the new black hole, all factors in Newton's law of universal gravitation are same.